We hear now Armchair Astronomy with members of the American Museum Hayden Planetarium staff talking to WBAI's David W. Teskey.
This is the 104th in our continuing series of programs on astronomy. Contributing their time and knowledge to this venture are members of the American Museum Hayden Planetarium staff. The topic of today's discussion is winter deep sky objects. With us today is Mr. James S. Pickering, Astronomer Emeritus of the American Museum Hayden Planetarium. Welcome back, Mr. Pickering.
Thank you, Dave. I'm glad to be here.
The winter sky is a blaze of stars.
The winter sky, well, it's too bad that it comes in the winter when the nights are so cold because people don't get out and look at it. But this is this region that we are in tonight is the most magnificent, both as to constellations themselves and to the individual objects in them. It's terrific. I suppose we might as well start at the top of things here, and the top constellation here, and this will be probably just a little bit east of the meridian at this season, is Armchair. Armchair is the charioteer. The constellation looks exactly like a kite, the regular standard two triangle shaped kites and so on. And it has, of course, one outstanding star, which you can look at if you want to, but it's Capella, which is a ridiculous name for a beautiful star. Capella means a little nanny goat, and why they call it that, I don't know, but they did anyway. I think Capella, incidentally, was the name of an astronomer who was a contemporary of Ptolemy's, but I'm not sure whether this star was named for him or not. But in any event, Armchair is, for its deep sky stuff, is famous for three open clusters, which are not too far apart and which are down in the body of Armchair. Now, remember I said Armchair was shaped like a kite. It has a shallow triangle at the top of it and a deep, almost equilateral triangle from wide where the crossbar of the kite would go, down to the bottom of the kite. Now, I suggest that you sort of creep along the lower eastern side of this bigger triangle. That will take you from Theta to Iota Aurigae. And you're about halfway between these two stars, a little less than halfway, counting from Theta, and just again a little below a line connecting them, is M36, Messier's number 36, which is an open cluster. Fairly standard cluster, but it's a nice one. Now, move up a little bit toward the northwest, about 2 degrees, and you'll hit that one was M37. I got my numbers mixed up. That's M37, the lower one. Now, up above it is M36. M36 is an open cluster of stars. Not quite in the middle of the constellation figure, and like the stars in that region of the sky, they're right involved in the Milky Way, and they're a little bit difficult to separate. But the most interesting of these three is just keep right on going in the same direction. M36, M37, M38 go right up in a line and are fairly evenly spaced, starting up from M36, which remember is about halfway between Theta and Iota and a little below. Now M38, it's shaped like a cross, definitely. I remember the first time I saw it, I didn't realize that. And the scattering of stars makes them look exactly like a cross. It's the top one of the three, 36, 37, 38. It's the top one of those three clusters. And this one, if you look at it, I think you'll be as surprised as I was. Of course, I'm tipping it now, but it's a definite cross-shaped cluster. The brighter stars just, I suppose, happen to be arranged that way, and it does have that appearance of a cross. Now, go right down below Aurigae, and the first star you'll run into is one that used to belong to Aurigae. It is now Beta Tauri, It used to be Beta Aurigii, but Aurigii has no beta now. This one was given to Taurus when the boundaries of the constellations were realigned back in 1930 by the Delport Commission. It's right on the edge. And this is El Nath, that which butts. It's in the conventional pictures of the constellation, it's the tip of the upper horn of Taurus. And below that, and a little bit to the east of it, about 5 degrees south of it, is the other tip of the horn, Zeta Tauri. Now this one's got a prize. Just a little bit above and ahead, what they call north preceding, to the west and to the north of it, is M1, Messier's first object, the famous Crab Nebula. Now, of course, in the photographs taken through the big telescopes, this is a highly explosive-looking affair, and it's magnificent. What you'll see will be a little bitty, faint smudge, but that's it. That is the remnants of the supernova of 1054 that blew itself into this cloud of dust. That's where the crab is, just a little bit above Zeta Tauri. Now slide down, and you'll run into Aldebaran, which will knock your eye out. I mean, it's a great, big, beautiful, orange-colored star. It's a double, incidentally, but you won't find its companion. Its companion is 11th magnitude. And the two stars, Aldebaran A, is first magnitude and better, and of course the little one is overshadowed. You won't spot it at all, but it's there. But in any event, just right to the west, and apparently almost surrounding Aldebaran, is the Hyades, which is a famous cluster of stars, fairly wide open and spread out. You can see that on a clear night. It looks like a letter V, kind of tipped over. And it is full of notable things. Theta Tauri, for example, which is one of the brighter stars in the Hyades, is a beautiful double. And if you poke around in there, you'll just run into all kinds of formations. Now, of course, this is one of the famous open clusters. It's one which is near enough to us. It's about 130 light years away, so that the stars appear fairly widely separated, but they're all the same color, all the same kind of stars, and so on, so they all belong to the same family. And of course, they are about 100 light years beyond Aldebaran, which is fairly close and doesn't belong to the cluster at all. But it's simply, in our line of sight, it's right in front of them. But go exploring in the Hyades. You'll find a lot of stuff there, and you don't have to work too hard. I mean, when you get it, just poke around and wiggle your telescope a little bit, and you'll see all kinds of combinations of stars coming in there. And then, of course, move up and to the west about 5 or 6 degrees, and you'll hit the Pleiades. And they are magnificent. There is an explosion in a diamond factory, if there is such a thing. Of course, traditionally, they were called long ago the Seven Sisters, but that was before they had factories and automobiles and other smog-producing devices. And from this part of the world, if you can see 4 or 5 Pleiades without a telescope, that's about par for the course. But in a 3-inch, you should see at least 75 stars there, and proportionately more telescopes of larger diameter. And they're magnificent. They're really blazing, hot, blue-looking affairs and lovely things. Photographs show a slight nebulosity around them, but of course that you won't pick up in any telescope. That appears only on the photographic plate. Its light is way up in the ultraviolet. It doesn't show there. But the Pleiades are the most distinguished open cluster, I guess, in the whole sky, and justly so. They are beautiful things. They are of an entirely different type of star than the Hyades are, and because they are at least twice as far away, I think they're over 500 light years away. No, 350. They look to be closer together. They're more compact. The whole business is. But don't miss the Pleiades by any means at all. Now we'll go downstairs to the king of the road, as they say, the head constellation of all of them, which is Orion, of course, dominating the winter sky. It's got more bright stars and more celestial wonders, more telescopic things in it, I think, than any other single constellation. And it is magnificent. Now, I would suggest, in spite of the fact that this may be a bit prosaic, take a look at Betelgeuse in your telescope and see how red that thing is. That is really red. There's no argument about it. It's a real red baby. And of course, Betelgeuse is variable irregularly and slightly, so don't worry about that. But it is a real honey. And the whole constellation of Orion is involved in an overall nebulosity, which of course takes long exposure photographs to see, but the thing is loaded with nebulae, and you're apt to bump into them anywhere. Take a look at the belt, the three bright stars, all of them at enormous distances, 1,600, 2,000 light years away. Big, hot Type O stars, terrific. And they will make their authority known through a telescope. I just look at them. You can't see anything, you can't do any research on them, and they're just bright stars. But they are bright. They're magnificent. Now I'll go down from south of the middle star of the belt. Climb down the asterism which is known as Orion's Sword, and take your time. I mean, just wander down there. There are all manner of things there. Single stars, stars in bunches, and of course right in the middle of this belt is the prize of them all, the Great Nebula in Orion, one of the very few of the hundreds of nebulae, clouds, luminous clouds, of which any trace at all can be seen with the eye alone. You can see that as just a faint, hazy-looking star-like thing there. But look at it, and look at it, and look at it. It's stupendous. To me, the first thing I think of when I look at the Great Nebula is the green flame of a blowtorch. It has a definite greenish color to the eye. Photographs, color photographs show it. There's all kinds of colors there, but the eye doesn't pick that up. Your eye isn't equipped that way. It looks definitely a pale, what you might call a coloromorphous apple green, you know, kind of that stomachache green that green apples get before they're ripe. Very pale green. But it is really something to see, even in a small telescope. You can't get the detail, of course, that a photograph shows you, but you've got something there, and there's no question about it. It's exciting. It just sort of explodes into your eye as you look at it and pick it up. You can't miss it. And if you've got a good night and lots of luck and a fairly strong eyepiece and a telescope that'll support it, you may see the little group of 4 stars called the trapezium, which are probably the stars whose energy excites the gases of the nebula into action. They are snuggled very close together, just about in the center of the brightest part of the nebula. This nebula is really, while it is really a single cloud, there is a streak of obscuring dust that cuts across it on a slant and really divides it into 2 separate clouds, M42 and M43 in Messier's catalog. And take the whole thing in. I mean, this dust is just a separation. You don't pick it up as obscuring dust in a small telescope, but that's what it is. And there is a little portion of the nebula below this cloud, which I know my father used to call it the fish's mouth, which is not a good name for it because that's what Fomalhaut means, the bright star way down near the southern horizon in the fall. But you can get this. This is not quite as hazy as the upper part, the fan-shaped part of the nebula, and you really can get a fairly good outline to it there. Now, as I say, that whole region is loaded with stuff, and it just move up and down that sword. You can spend an hour with a small telescope on that thing without getting bored or tired or anything else, and it's a magnificent part of the sky. If I were you, take a look at Rigel, which is an extremely bright thing. It's Rigel has an absolute magnitude of -7, making it about 25,000 times as bright as the sun, but it's 900 light years away. But it asserts its authority again through a telescope. And explore all over Orion. I mean, there's so much there. It's Rigel, incidentally, is a double star, but it's not easy. It's like Aldebaran. It's got one very bright component, one very faint one. Down below Orion is an inoffensive little constellation with an inoffensive name, which is Lepus, the hare. And there's just one thing which I would like to call your attention to in Lepus. It's a variable star, and its designation is R. Leporus. Now, Lepus, to me, looks like a poorly tied bow tie as you look at it. There are 6 principally bright stars in the formation, 2 lines of them. The upper line of 3 is just slightly curved up in the middle, and the middle star is the alpha of Leporus. And the lower line, 2 stars travel along parallel to the 2 in the upper line, and the third one to the west drops way down. Now, to find R. Leporus, follow along the upper line and keep on going about 2 degrees, and you will see R. Leporus. Now, this has been known for some years as Hind's, Hind', Hind's Crimson Star. Hind was an astronomer of the old school, and he observed this star, discovered its variability and so on. And it is crimson. It's a drop of blood up there. See if you can spot it. It's not very bright. It's a little difficult to find, but you'll know when you have it. It's really a brilliant ruby red. Hind's Crimson Star in Lepus below Orion. Now, I would suggest that you move off to the east into a very dull company of Monoceros, the unicorn, which lies to the east of Orion. Its upper dimension, its north and south dimension are about the same as Orion's, but there's very little there. There's just one open cluster. That is M50, number 50 in Messier's catalog. And if you follow along from the Great Nebula, work your way east for about 6 or 7 degrees, and you'll run into this. And here again, it's in the middle of the Milky Way, but you'll know when you have it. I mean, it's a definite cluster, a good deal this side of the main stars whose light makes the Milky Way, and it stands out there. Now, we ought to go upstairs again, I think, to Gemini, the big twins up there in the sky. Now, Gemini, of course, Castor and Pollux are the 2 principal stars. Castor is they're on a kind of a slant from southeast to northwest, rather sharply inclined. You can't miss them, the twin stars. They're not twins, though. Pollux is a good deal brighter than Castor, although Castor is the alpha and Pollux is the beta, but old man Bayer got a little bit careless there, I think, and so on. But Castor is a complicated affair. There are 2 stars, and you may have trouble separating them. They're very, very close together. One is 2nd magnitude, and one is nearly 3rd, about a magnitude fainter. You ought to be able to do it, but you, as I say, lots of luck. I mean, it's not easy. The interesting thing about it that each of these 2 stars is, again, a spectroscopic binary. You've got a complicated system of 4 stars all going around themselves and each other and so on and so on. And then, to make things worse, there's a 3rd star in the system. So you've got 5 stars in a very, very complicated set of orbits, all gravitationally connected, a kind of, I don't know what you'd call it. 2 stars is a binary, and this is a cinquentenary or something like that, involving 5 stars anyway. But with luck, and only with lots of luck, can you separate the main components of Castor, the big double. But don't give up on Gemini. There is a beautiful, very beautiful open cluster way over to the west, above, well, almost above the side of Orion. Go upstairs from Betelgeuse and just a little bit to the east. Gemini, you know, is really two irregular lines of stars running from Castor down, below Castor, one line working down to the southwest, and then below Pollux, another line working down to the southwest. Well, stick up in the Castor line, and you'll come down to two stars, fairly bright, fairly close together. These are Mu and Eta Geminorum. Now, Eta is called Propus. That's its Greek name, which means the frontward foot of one of the twins. And just a little bit above and to the west of Eta is M35, which is an open cluster there, and it's lovely. It's really worth the trip. I mean, don't neglect it. Go find it and take a look. It's a beautiful affair. Now we've got a planetary up here, which is difficult to find, but which is worth the hunt. Delta Geminorum is the key star. Now, Delta is about the middle star in Pollux's line, the lower line of stars. You go down, there's Delta, while it is in that side, is also one of the corners of a little triangle in Gemini, which sticks out to the southeast. Here you've got these two lines of stars, and in the bottom line there's a little protuberance, which is this little triangle, and Delta is the first star to the east in the triangle. Lambda is the bottom peak of it, and Sigma is the other one. But go to Delta, and there you've got a 2 degrees south following Delta, and this is one Messier didn't pick up. It's one of Herschel's. Is a planetary nebula, which is worth finding. It's again one of those little disc-shaped aggregations of gas, usually surrounding a hot central star. You can't see the hot central star. In fact, I doubt whether the telescopes we're talking about will pick up the central star in any of these things, but they're there. But see if you can pick that up. It's worth trying for. Down in the bottom, we've got Canis Major. That's go right down from Gemini. You pass Canis Minor, of course, which has Procyon in it. That's a double, but of course its companion is a white dwarf and so much fainter than the main star in Procyon that you haven't got a prayer of seeing it. And same way with Sirius in Canis Major. Visually the brightest of the nighttime stars, but bright principally because it's close. It's only eight and a fraction light years away, and actually only 25 times as bright as the sun. Compare that with Rigel, which is 25,000 times, but 900 light years away. Sirius is a double. Its companion was the first of the white dwarfs ever discovered, called the Pup, Alpha Canis Majoris B. But Sirius is first is minus 1.5, and B is +8, and it's all snuggled right up close to Sirius. You can't possibly spot it. It took them 10 years with the big major telescopes before they saw it, knowing it was there someplace. So don't be disappointed if you can't see it. But go right on down below Sirius, about 3 degrees, and you'll run into M41, which is another open cluster. Beautiful, beautiful thing. And it's got a fairly ruddy star right in the middle of it. The rest of them seem to be packed around that, but don't miss that. That's worth looking for. You're getting pretty far south now, you see. This is 25 degrees. Well, M41 is a little more than 20 degrees south declination, and of course that's about the limit of the standard horizon around here with houses, trees, etc., 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 although theoretically we should see to 40 south. We rarely can. You've got to knock off about 20 degrees for that, for obstructions in atmospheres and irregularities of terrain. But you ought to be able to find M41 without too much trouble. This part of the sky in the cold winter nights is splendid. It's really one of the most spectacular of the lot. working right down from the top. You've got Arija the charioteer, and below it is Taurus, and below it and to the west. Then, of course, comes Orion, the chief of them all, and you can spend a lot of time in Orion just poking around. Of course, there are a lot of things in Orion which everybody knows about, but we can't hope to see them with our type of telescopes. That is the Horsehead Nebula and two or three associated bright nebulae there. There's nebulosity in connection with the three belt stars, and some of them make fairly bright patches in photographs, but don't hope for them in your 6-inch reflector or 3-inch refractor, because it just takes more of that, time exposures and so on, to bring them out. But don't miss the great nebula again, and go over and see what you can do with Castor. That is a challenge. See if you can split it, and find the open cluster, the open clusters in Orion, the open cluster in Propus. They're all associated with the Milky Way, and some of them are difficult to separate from the general lovely confusion of the Milky Way, which is just magnificent. Just poke around there and you'll see stars that'll last you for the rest of your life. Of course, they're all up there, all kinds, all shapes and sizes and pairs and everything else. And then go down and say hello to Sirius and drop down to M41. And by that time, you'll probably be frozen stiff, so you better pack up and go to bed.
Very good. Thank you very much, Mr. Pickering. We have been listening to Mr. James S. Pickering, Astronomer Emeritus of the American Museum Hayden Planetarium, discussing deep sky objects of winter. We hope you will be with us next week, and if you have any questions or topics you'd like discussed on future programs, indicate them by card or letter to Armchair Astronomy, WBAI, 30 East 39th Street, New York, 16, New York. We will try to answer as many questions as possible in future programs. Until next week, good day.
This has been Armchair Astronomy with members of the American Museum Hayden Planetarium staff talking to WBAI's David W. Teskey.